Hello, and thank you for joining us today for our webinar. We're going to be talking about our EZ8 control panel, which is part of our M1 family, and try to give you a new perspective on how this product can be used for applications that aren't necessarily directly related to it being used as a security system. My name is Amy Strickland, and I'm with our tech support and marketing departments here at ELK. Joining me today is Brad Weeks, who is the manager of our tech support department.
Good afternoon, everyone.
So we're talking about our M1EZ8 today. You may be familiar with the EZ8 as kind of the little brother to our M1 Gold system. Has a lot of the same features and capabilities of the M1 Gold, just a smaller version that is lacking in some features like the voice and that sort of thing. But the EZ8 is really well suited for programmable controller type applications. So it's a different way to look at this product other than just a security system. You can be looking at it as a way to kind of fill those unusual and offbeat kind of requests that you might get from time to time. So looking at the features of the board, you've got 8 zone inputs on board. You can expand that up to 200. We have 1 Form C relay on board and 10 low current voltage outputs. That is also expandable up to about 203 outputs, and that can be relays, voltage outputs, or a combination of the two. The EZ8 has a built-in astronomical clock for date and time or light and dark triggering, so it knows the days of the week, the date, the time, and it also is able to calculate sunrise, sunset so that it knows when it's light or dark outside. We have up to 64 counters and up to 206 timers or phantom outputs, and we'll get a little bit more into that as we go along. And it also has support for serial and IP-based communications for interfacing with other systems that may be able to talk to the controller in that manner. So I just want to point out some of the important features as far as the layout of the board, things that you need to know just to familiarize you with it if you're not already familiar with an EZ8. You've got your battery leads and your AC input here at the top. You can see that's where you're going to bring power into this board. There is a data bus. It's a 4-wire data bus, and that allows us to add expansion devices and that sort of thing. And you could even add keypads, of course, to this. And again, the basis here is that it is a security and automation control, but you can use it in other ways. So you don't necessarily have to have a keypad connected to it there, but you do have a data bus for that purpose, as well as adding more zones or more outputs or serial interface devices, that sort of thing. There is 1 Form C relay on board, that is output 3. And then along the bottom side here we have our onboard inputs. You've got your zone 1 through 8, and each one of those shares a negative in between. So zone 1 and 2 share a negative, 3 and 4 share a negative, and so on. And then the voltage outputs are accessible through the connector that you see on the middle of the board there. And you have like a ribbon cable with flying leads that you can connect to that, or you can convert that to relays with another expansion board, which we'll go into here in just a moment. Now I want to talk a little bit about an existing product that we have called Magic Module. You may or may not be familiar with it. It is a programmable controller product, a 4-input, 4-output device. And we've had a lot of people over the years use that product for a variety of different applications. Brad's done a number of different programming specialty custom programs for that Magic Module. Magic Module is a little bit more difficult to work with. It is an older product, and you do have to know a programming language and that sort of thing. So I just kind of wanted to give you a comparison of the EZ8 versus that Magic Module. There are still some cases where Magic Module might be a great fit for you if you just need a few inputs, few outputs, and you're not looking for any extra expansion capability, that sort of thing. Another thing, is like your date and time scheduling. You're going to be able to do that with EZ8, but you won't with Magic Module. Same thing with temperature sensors. Magic Module is not going to be able to support those. Serial communications, Magic Module can support serial communications. That's a single connection only at a fixed baud rate of 19.2. serial communications with the EZ8, you're going to be able to have up to 8 serial devices interfaced with it, and you can configure the baud rate from anywhere from I believe it's 300 up to 38.4 on the one expander, and then our main interface can actually go up to 115.200. And again, we'll dive into that a little bit deeper here in a moment. EZ8 does have the option to support IP-based or LAN-based communications and also provide email notifications with an add-on module. Those things can't be added to the Magic module. And as I mentioned before, programming requires a lot more knowledge of the language and how it works with the Magic module. It's not as straightforward as you're going to find it to be with the M1EZ8, which is just very easy. And Brad's going to show us just how easy as we get to the second part of our presentation today. Again, I'm going to dive just a little bit more detail into inputs. As I stated before, you've got 8 on board. They're located on the bottom there where I have that nice orange circle around the circuit board there in the picture. These zones will support normally open or normally closed devices. And if you have a need for end-of-line supervision, that's supported as well. We also have a zone definition that supports analog zones, and so that is for triggering based off of the variable readings of a device that has variable resistance. As that resistance changes, we're able to see how that manipulates the voltage on the zone and trigger that. But again, you're looking at variable resistance on analog zones. If you do need to add more zones to the system, you can add them with an M1EZ8, which is an input expander. That's going to add 16 more zones to the system. It connects to that 4-wire bus, and you could have up to 12 of those added to get an expansion capability of 200 zones. One thing that you can do with EZ8 that again is just not available from the Magic module controller that we currently offer as a PLC device is temperature sensors. So the EZ8 could have up to 8 of those temperature sensors. They must be connected to those main board zones. And we do have one with an internal probe and also one with a external probe. That's a 7-foot wire with a stainless steel probe at the end. And your temperature readings are going to be anywhere from -50 to 120 degrees Fahrenheit. So that can be really great for monitoring temperatures in a variety of different applications, both residential and commercial. I pointed out earlier, and again I've got kind of marked on the circuit board here where your outputs are on the board. Output 3 is a single pole double throw Form C relay. You can use that to switch power to higher current devices. Outputs 7 through 16, which again are on that connector more towards the center of the board, you're going to have a ribbon cable going to that. You've got 10 milliamp 12 volt DC triggers there, so that's going to be good for low current triggering or driving those very low current devices. The other option that you have with that is to actually convert those to relays. If you connect the M1RB via a ribbon cable to that connector, then you're going to have 8 more Form C relays. Need even more outputs or more relays? We have an expander that connects to the data bus. That's the M1EZ8, and that has 8 relays, 8 voltage outputs. And you could actually get 16 relays out of that by adding an RB to the M1EZ8. So you've got a lot of expansion capability here to have as many inputs, many outputs as you need to cover your application. So scheduling can be really helpful and really important when you're doing these types of applications with a controller like this, and the M1EZ8 does have the astronomical clock built in. That allows it to know the date and time, and it can also trigger things based on days of the week. So if you have some kind of schedule, something's supposed to happen one way on Monday, Wednesday, and Friday, and differently on Tuesday and Thursday, then you're going to be able to specify the days of the week as well. You can also do periodic triggering. You have, every X seconds, minutes, hours, that sort of thing, so that you can have that kind of conditional, it's checking a certain condition every so often or that sort of thing. And then another really nice feature is the sunrise sunset. So you can put in either the closest city if you want to just do the easy setup, or if you want to enter your exact latitude and longitude, you get more precise calculations. Then this system is going to know when sunrise and sunset occur so that you can use those as conditional parameters in your programming. Another very helpful thing when you're doing these types of programmable, logic type applications, we have counters. The counters, you can set a value, you can add to them, subtract from them. You can compare the value of a counter for that conditional logic. So you're, saying whenever this happens and this counter is, greater than or less than a certain value, that sort of thing, then you're able to trigger. You can also actually trigger an action based on the counter changing to a certain value. So actually changing state from, say, 9 to 10. When it actually changes to 10, you can trigger there as well. There's also timers that you can use, and this one's a little bit kind of a neat programming trick that we do with the EZ8, using what we refer to as phantom outputs. So again, the output capacity of this system is pretty high. You can go up to like 203 outputs. So in most applications, you're probably not going to be using that many physical outputs. Any output that doesn't physically exist can be used as a timer or even used to flag a condition. The way that the timer feature works, you are turning on that output in programming for X amount of time. That can be for a few seconds, few minutes, hours, however you want to set it up there, but you're turning it on for a certain amount of time, and the system is able to keep track of the state of that even though there's no physical output there. So then you can check for that output state in a conditional statement to say, when this happens and this output is on or it's off, that has to be met at that time. So you can have that conditional logic, or you can actually trigger off a state change again, similar to the counters. But again, the phantom outputs is one of those neat little programming tricks that Brad will tell you a little bit more about as he gets into showing you some of the programming options. So serial communications can be helpful in interfacing with certain pieces of equipment. You might have like some type of pool or spa system that you want to interface with, or one example of something that one of our installers used the system with was to control some equipment that was part of like a personal observatory. And so those types of things, you may not be using just a physical output, but actually need to provide some ASCII serial communications, and we can certainly do that with the EZ8. So we have two different options for adding a serial port to the EZ8. The first option that you always want to consider is what we refer to as the main serial interface. That's going to be the M1EZ8 MSI. That has a configurable baud rate up to 115/200, and it's assigned as port 0 in programming. Now that port number is important when you're actually writing your rules, and again, Brad will hit on that a little bit more here in just a bit. It connects to the J5 port on the EZ8 board, so it's just going to plug right in, and then you have your DB9 connector there. The other option, if you do need to add additional serial devices, maybe there's a couple of pieces of equipment that you're wanting to interface with for your custom installation, that would be the M1EZ8, which is a serial port expander that sits on the data bus of the EZ8. Its baud rate is configurable up to 38.4. And the port number, which you would reference when you're writing your programming, matches the data bus address of that device, which is set with dip switches. So two different ways to get you a DB9 connection for interfacing with specialty equipment. Another option for interfacing with specialty equipment, everything's IP. You're constantly hearing Internet of Things these days, so everything's connected to the Internet. The EZ8 can be connected to the Internet using the M1XCP Ethernet interface. This does connect to the main serial interface of the EZ8, so if you do need to network the EZ8, you're going to have both that MSI and the XCP part to make that happen. But what that's going to do for you is allow you to send custom ASCII strings to a specified IP address, and you could program up to 8 IP addresses in the system if you have more than one piece of equipment that you're interfacing with. And we can also react to custom strings coming into the EZ8. Another thing that this adds is the capability to send up to 16 different customized messages. So you're programming in an email address and then the message that you want sent to that, and you have 16 slots to do that with. So if you are working with an application where maybe you're, say for example, monitoring temperature and you want to provide notification when the temperature is out of a certain range as one of the actions when you're monitoring that, you could send email or text notifications through the XCP. As I said before, programming really couldn't be easier. You're using the ELK-RP programming software. If you are working with our M1 controls for security and automation, you may already be familiar with this software. But it's really easy to work with. Everything's in simple English text. You don't have to know any kind of programming language. You are simply making selections from a drop-down menu, possibly checking some boxes or making some other selections, and then if you want to enter some descriptive text as to what you're doing, you're entering that. But beyond that, you don't really have to know any kind of programming language or any, worry about how things are, syntax and that sort of thing, because we're actually going to be able just to build these rules just by making these drop-down selections. Rules are based on whenever and then type logic. So we have a triggering event, which is your whenever, and your and statement is conditional. That is something that must be true at the time that the whenever or the triggering event occurred. And then of course your then is the action that you want to occur, whether that be controlling an output or sending a message or sending a particular serial string, whatever the case may be. So at this point we're going to go ahead and hand over to Brad, and he's going to go over some of these examples that you're seeing on the screen now. We also just for fun wanted to show you a cool project that one of our engineers got into. He took an EZ8 board and was able to make an IP controlled RC car out of it, which was just really cool. It had a camera on the front, you can see kind of the router on the back and that sort of thing. So a lot of different neat things that you can do with the EZ8 besides just using it for a security system, and that's what this is about today. We want to get your gears turning on it. So I've talked here about the hardware. Now I want to hand it over to Brad, and he's going to really get your gears turning with how you can start to really use this stuff that I've been talking about.
All right, Amy, certainly do appreciate that, and this would be a good opportunity to maybe pause for just a second to see if we have any questions yet or anything.
No questions at this time, but definitely if you have those questions, please send them in to us. We will definitely be addressing those for you. We'd like to check those out. So yeah, send those questions in, but let's go ahead and go over what we've got to go over, and we'll have a Q&A session at the end.
All right, excellent. So once again, thanks to Amy for putting this together and for the information here at the beginning. And right now we want to dive into some possible application examples. Using the M1 zone temperature sensor, we can monitor temperature. You can have 8 of those sensors on the EZ8 board. We can use the dry contact feature of the EZ8 in order to monitor humidity through dry contact, or maybe a moisture sensor, something along those lines. We've had examples where we've used the EZ8 in a brake bell application, perhaps a school type application to announce when classes start and end. The RC car is just an excellent example of thinking outside of the box. I mean, who takes a security system or automation controller and turns it into an RC car? No one that I'm aware of at this time. There we go. And we do have some capability of some light access control with the EZ8 and specialty timers. So just to give you a little bit of a background, in 1998, Elk Products released the Magic Module series, and that was Elk's stepping stone into the automation arena. We came out with two versions, the 443 and the MM220, but it did require the installers to learn a new programming language. Now, some applications were fairly simple, so it really didn't pay the installer to have to relearn a programming language. So in some cases I'd help write the program for them and so forth. But with the EZ8, the programming is so much simpler and very user-friendly that probably not a scenario now that would require any additional knowledge of programming software. It's all built into the Elk RP programming language. So let me close this here and get to RP. There we go. All right, so what I've done is opened up RP, and what I'm going to do is I'm going to create a default account for us. So first thing, we'll go File and New Account, and for today I'm just going to call it Training. Now under my system type we have the two options, the M1 Gold and the EZ8. Today we're talking about the EZ8. The serial number is located on the EZ8 board. It was in one of the diagrams previous. It's a white sticker. It's an 8-digit number, starts with the number 4, unlike the M1 which starts with 0. Example of an EZ8 serial number, my RP access code. I just wanted to create a default account. So I'm going to click OK. And right now I'm looking at our account details screen. It's a clerical screen for information about the site, some generic information you could put in the notes. Once we connect to the system information will automatically fill in and so forth. Let's jump over to zones. Let's jump right into zones, for instance. So if we click on zone inputs and we have our main board. Now the first 8 zones on the EZ8 will support the zone temperature sensors. So if we click on zone 1, for instance, this may be a greenhouse. So this may be zone 1 of the greenhouse. And the definition will be temperature. So we'll scroll down in our list until we get to number 33, temperature. Now it's always going to be a normally open, and we want to make sure if using our zone temperature sensor we have the fast loop response. So as far as setting up the zone for a temperature sensor, this is all you have to do, plus make your 3-wire connection to the zone temperature sensor. In the rule engine is where we'll periodically check for the temperature, and if it's above or below a certain set point, then we can have a rule fire. Now, I could set up all 8 zones for temperature if I wanted to, and then if I have additional zones I need to configure, let's say it's for those moisture sensors, those dry contact moisture sensors, I could right click on zone inputs and I'm going to create a new hardwired group. It will be group 2 starting at zone 17. And let's say for instance zone 17 is a moisture. Now this is going to be a non-alarm zone, so we're going to configure it as 16. It's going to be normally open, and we don't have to worry about any of the other attributes at this time. We're going to use it in the rule engine, and I could do this for additional type zone inputs. Let's say maybe it's light manufacturing. We want to monitor a proximity sensor on a conveyor belt or something, and as long as it's seeing devices go by, it's fine. But if it fails to see a device go by and the zone opens or closes, we could use that in rules to maybe flash a light or something to give a visual indication that the conveyor has stopped or a malfunction has occurred. Let's go under automation, and I'd like to go under text real quick. Amy talked about being able to use the M1EZ8 and our serial port interface to possibly talk to other pieces of equipment that we don't currently directly talk to. And we can do that through their ASCII protocol. So as long as we know what their ASCII protocol is, we can write strings that we're able to send and receive back and forth using the M1EZ8, the serial port expander, or it is also possible to do it over the local area network through the M1EZ8 to an IP address. The additional details on that are available in our RS-232 ASCII protocol, which is available on our website to download as far as setting that up. But I will go over it real quickly. If we go back under the XEP setup, we have our central station tab. Oops, need to create a telephone number first, sorry. Telephones, I'm going to create one telephone number, and for this case it'll just be IP communication, and the format will be 6IP. Do not need these. So now under this screen I can tell it what IP address and port number I'm going to be sending and receiving data on. So it might be, and it'll be the non-secure port 2101. So that information is to allow the XEP to send and receive ASCII strings over the local area network to another device that's connected to the local area network. So back under text, now let's say for instance we have our XSP talking to a third-party device to their serial port. We know what their string is, and the string may be pump on, and it may be followed up with a line feed and a carriage return. You can always insert that line feed carriage return, and basically that string is done. If that's the information that they send, pump on, then they may have another one for pump off. Oops, there we go. Alright, so I've created two strings. I can use them in the rule engine that whenever this string is received, I can do something, or if I need to send that string, I can send that information out through the XSP to a device. So the real beauty of the M1EZ8 and thinking outside of the box is the rule capability. So within the rules, we have our whenever statement. That's our trigger event. That's what happens when a temperature and input, phantom output. We have a number of different whenever events. So under time occurrence, whenever the time of day equals a specific hour. If it's at sunrise or sunset, it can be minutes before or minutes after. On the hour, on the minute, or every second, or a combination of maybe every 15, 20, 30, 60 seconds. It's whatever you want to configure your time occurrence. We can have whenever statements based upon a zone changing state, and that zone can be violated or secure. We can have our whenevers on an output change. If we have one rule that says turn the output off, whenever that output turns off, do something different. That can be a whenever event. This is for keypads, the keypad change, key fobs, lighting, automation tasks, and so forth, the security. Right now we're talking more kind of outside the box. So let's do a time occurrence. Let's say for every, let's see, every, I want to do something every 15 minutes. Okay, I want to check that temperature on that first zone we created, that zone temperature sensor. So since temperature really doesn't change that quickly, you don't have to check it that often, but every 15 minutes, 10 minutes, something along those lines. And we say, and let's go to temperature. And since I've already defined zone 1 greenhouse, I can say, okay, what is the temperature? Is it equal to a certain value? Is it less than a value? Is it not equal to or greater than? So I'm going to say every 15 minutes and the temperature is greater than a fixed value of 70, and like Amy said, we can go from minus 50 up to 120 on the zone temperature sensor. So every 15 minutes and it is above 70, okay, I want to then turn on an output. Now that output might be controlling a fan or a heater, so I want to turn that output on. And that rule is done. So every 15 minutes it's going to check that zone temperature sensor to see if it's above 70. If it is, it's going to turn the output on. Rule is done. Now what happens when the temperature drops below that? Okay, so we do another whenever, once again based upon time occurrence. Okay, whenever every 15 minutes and the zone temperature sensor is less than 69, okay, what do we want to do? Well, we want to turn that output back off. So we're going to turn output 3 off. All right. So now those rules are done. Very simple as far as checking, and I could write one for every zone that every 15 minutes it checks each, it'd be an individual rule to check each zone for the temperature. If it's above or below, do something different. Let's say, for instance, we are interfacing with that third-party equipment, and if the temperature does get greater than 70 degrees, not only do I want to turn output 3 on, but I also want to send out a custom ASCII string. So how do I do that? I'm going to add another then statement. I want to send text port, or send text out port. I'm going to turn that pump on, and I'm going to send it out port 1. I do apologize that that one's not showing up there, but that'll be through port 1 right there. See, and that'll be the XSP, the serial port expander, and that's set to address 1, so it's physically connected to that third-party equipment that's going to be controlling the pump. So now I've told the system that whenever the temperature gets greater than 70, turn our output on. Also send this signal to the third-party manufacturer to turn their pump on. So real simple within 2 rules. I'm doing multiple different things here based upon the temperature being above or below 70 degrees. I can also edit the rule so that it looks for specific days of the week. That's our and statements here. Or specific time of day, day of the week, whether it's dark or light outside, based upon another input. Maybe all this is based upon the moisture sensor being not secure. If you're doing an automation, automating an irrigation system, you may not want to turn your sprinklers on after it's been raining like it has here for the last 4 days. So if you set up your irrigation system to turn on every day or every other day, if it's been raining, the moisture sensor is wet, that sensor is closed, you don't need to turn the sprinklers on. So that's the value and the benefit of having the additional and statements. Now, these are optional. You don't have to have them, but they're there as conditioning statements. So we can base it upon time, date, whether it's dark or light outside, the status of a zone, the temperature. We could have it compared to another temperature sensor that we have configured. You can have multiple and statements within a rule, but each and statement must be true before it will drop down to the next one. And then the then statements, they fire one after the other, and you can have multiple then statements like we have in our example. So let's look at whenever the zone input change. We have our moisture sensor, that's zone 17, moisture. So whenever that zone becomes not secure or it's detected moisture, what would you like to do? Well, maybe perhaps you need to send out that email. If you have the EZ8 tied in with the ELK M1EZ8. You can have up to 16 predefined email messages so that when moisture is detected, it can then send an email out to someone to let them know that the moisture's been detected. Maybe there shouldn't be moisture at this area. So that's a good way to alert someone that there has been an indication of moisture. You can also turn on additional outputs so that the output's a visual indication, maybe a strobe or another LED or something. You could have the output control a sounder so that you get a warning sound when a condition is met. Also under whenever, we can do the counters so that when a counter, like Amy said, we have up to 64 counters. Those count from 1 up to 65,535 so that you can base something upon, every 10th trip or every 20th trip have a different event take place. So that's the intelligence built into the EZ8, is the ability to count up or set a counter to a value or decrement a counter, and then based upon the counter's value being exactly equal to something or greater than a preset value or less than a preset value, you can have different rules activate. We mentioned some light access control earlier. The M1 has access control capabilities. You can have up to 16 readers connected to a system. Those either connect to the back of an ELK keypad or to our access control module, so that you could have, whenever access, that's under the security aspect of it, but that's whenever access on a particular keypad, keypad 1 is triggered, you need to release a door. So that too could be a physical output on the system. You can base upon the access and the time of day, so that whenever the time of day is greater than let's say later than 7 a.m. and the time of day is less than, earlier than 5 p.m., we want to turn on an output to allow that individual in, so that they're not 24/7. They're only allowed access from 7 to 5. We could also restrict them based upon the days of the week, so that they're only allowed access Monday through Friday, or Monday, Wednesday, and Friday, or maybe just Mondays. The specialty counter or specialty timer aspect of it, we talked about using the phantom outputs. This is a good one that comes up a lot with the Magic module, is delay first. An event takes place, we need to delay first for a certain amount of time and then do something. So the way we achieve that, let's say for instance, whenever we have our zone, we'll pick on zone 2 this time. Whenever zone 2 becomes not secure, I then turn on a phantom output. And we'll say go high in the list. That was because it's probably not being used. So we'll pick on zone or output 100. We're going to turn output 100 on for a duration of, let's say, 30 seconds. Okay? Then turn output on for 30 seconds. And that rule's done. So what happens after 30 seconds? Well, new. Whenever, this is when the output changes. So whenever the output actually turns off, we want an event to take place. So we're delaying, let me select output 100 here. So whenever that output state turns off, I've now can maybe send an email message, or adjust a thermostat, or maybe control a different output. So I want to turn my fan back on. So I'm going to pick on output 3, my fan. I'm going to turn him on for 2 minutes. So when this zone becomes not secure, I'm going to delay for 30 seconds. That's my phantom output. And when output 100 is turned off, the 30 seconds later, turn output 3 on for 2 minutes. So this is our phantom output. This is an unused output that we're simply using as a delay first, or it could be used as a flag. We use counters too as flags. We can toggle a counter between 0 and 1 and have that counter, when it equals 0, do one thing. If the counter equals 1, we can do a different action. If we're incrementing the counter each time the zone changes, like I said, once it reaches 100, we can have something totally different happen. Amy, do we have any examples? Anything anyone would like to discuss right now based upon some of the examples we've thrown out so far?
One thing that's come up is related to the ASCII strings, and so the example or the question is, can you have it when one string is received on one port, send out a different one on another port? And
Sure.
you certainly can do that. So will you show us how that works?
Sure, absolutely. So here, let's go whenever, and sorry, whenever text, ASCII string text is received. So whenever this is received on port 1, let's say the pump turned on manually itself. It sent pump on to the EZ8. Okay, so whenever the following text is received through port 1, I then maybe want to turn off a different pump. And that would be a different ASCII string perhaps, but just for simplicity here, let's say we're going to then turn around and send pump off on port 2. So I received it from one piece of equipment. The M1 processed the rule, said, okay, I received this on this port, port 1. I'm now going to tell another piece of equipment. Now this will require 2 M1EZ8s. You can have a total of 7 of them on the data bus. So we can integrate with 7 different pieces of equipment using this fashion here. We now can receive on one port, process the rule, turn around and send that information or send a different string to a different piece of equipment through port 2 or the XSP set to address 2. Does that help?
Yeah, it does.
Okay, good.
Okay, so another thing that's come up is the capacity for these types of logic statements, these rules. Can you touch on how that works and how you can tell what you've used and what you have left and that sort of thing?
Sure. Okay, everyone take a look at the bottom of the screen here. By definition, a rule consists of a whenever event. You can only have one whenever in a single rule. You can and a single then is considered one rule, and you could have up to 528 rules. When you add additional ands and thens, that takes up an additional rule space, as well as the for. Like I said, turn on for X number of seconds earlier. So right now I've created 5 rules, and I've used up 2% of my rules in text space availability. So as you're adding rules, you can look down here to see just how much of the EZ8's rule capabilities that you've used. When you're under the text, that too, every 8 characters in a text message is equivalent to 1 rule. So that's take that in consideration when we're creating those custom text strings, as well as when we're writing our rules. But I have 5 rules so far. That's sending and receiving text, is checking for temperatures, and I've only used 2% so far.
Thank you for that. So yeah, you can
Okay.
see that it's hard to really, like, 528 is a number of rules that it will hold, but it's really hard to pin that down to, for your application. It's going to vary depending on whether or not you're using text strings, how many ands and thens and fors you have in the rule, as to how many rules that actually adds up to. So we just felt like the percentage thing was a lot easier for you to keep up with what you've used and what you have left based on what you're doing, which is going to be different all around. So I know that we talked about counters and you sort of hit on counters, but could you
Mhm.
kind of show us, just kind of step us through an example that would maybe set the counter to a value and then subtract from it under a certain condition and then trigger when that counter reaches, 0 or
Okay.
reaches a different number?
Sure, sure, absolutely. Now earlier I did a phantom output that delayed for 30 seconds. I could easily have done a counter using the same method, and in some cases this may be better. So let's name this counter, and we're going to call it delay first. Okay, and I'm going to create my rule. I'm going to say, okay, whenever, let's pick on zone 3. So whenever zone 3 becomes not secure, okay, I'm going to then set the counter. So I'm going to go set delay first. I'm going to set it to a value of 30. Okay. All right. That rule's done. I'm going to show you what we're going to do with that. So when the zone initially became not secure, I set the counter to 30. Now then, I'm going to say that whenever time occurrence, I'm going to say every 1 second, okay, and the zone is not secure. So let me find my zone in zone 3. It doesn't have to be zone 3. It could be another zone, but I'm using this in the example is not secure. I want to then subtract from the counter. So let me find my counter. I'm going to subtract a fixed value of 1 from this counter. Okay? That rule is done. So whenever the zone becomes open, I set the counter to 30. Every second and that zone is still open, I'm going to subtract from the counter. So that, new rule, whenever that counter actually equals 0. Whenever counter 1 is equal to 0, I want to then, I'm going to turn on output 7. That's going to be some sort of sounder. And I'm going to turn it on for a duration of 5 seconds. Okay? So what's a good example of this? Well, this could be a good door prop. So you have a zone, maybe leading to a freezer or something. Employee opens the door, they go in, they get what they need, they forget to close the door. Well, 30 seconds later, it's going to tell you that output 7 is going to go off for 5 seconds to say, hey, the freezer door is still open. So somebody could go close the door. So that's how we can use a counter. We set it to a value. Every second and the zone is not secure, we subtract it from it. Now if the zone had become secure, it wouldn't subtract. It would stay at that last value there. And when the zone reopened, it's going to reset it back to 30. So it's an ongoing process here. We set it, we subtract from it as long as it's open. If it ever reaches 0, set off an alarm.
And with this type of application, it would be really easy, say, that output 7, you're making that announcement or that sounder. Say if you wanted to repeat that again a minute later, it would be pretty easy to add that to this sequence. Could you show us that just as, just a quick
Yeah,
edit?
sure, absolutely. So we turn the output on for 5 seconds here. Let me edit this. Let's use another phantom output. So let's just say, okay, so I'm going to say output 101. I like to go high in the list. Turn output 100 on for 1 minute. Okay, and whenever, new rule, whenever output change whenever output 101 now turns off, okay, and the zone, let's say that was zone 3. Zone 3 is not secure, meaning they've still left that door open. I want to then turn output 7 back on for my 5 seconds. I'm going to give them that little 5-second blurb to let them know you've left the freezer door open again. And I want to turn output 101 back on again for 1 minute. So as long as that freezer door remains open, every minute they're going to get an announcement that the door is still open. So make sure I got that right. So whenever output 101 state is turned off and the zone is not secure, turn on my audible alert, then I'm going to turn the output back on for 1 minute. And then that rule is done.
Great, thank you.
You're welcome. So right now we've given just a few examples of some things that we've come across over the last few years. Specialty timers, brake bells, school bells, some irrigation control, temperature monitoring. An amusement park has used the EZ8. That's just and we've made an RC car out of an EZ8. So that's just thinking outside of the box a little bit as far as some of the applications that you could use a programmable logic controller. So it's not necessarily security related, not really an automation controller, but is a specialty programmable unit that can do a variety of different things. So we hope that we've maybe planted a seed on some applications that you may have where you say, well, I wish I had a solution for that. The EZ8 might be a good solution that you never considered. More powerful than the MM443, has more features, more expansion capabilities, networkable as far as putting it on the local area network or accessing it outside your local area network through the XEP. You also have your email capabilities within the XEP and so forth to alert someone that there has been an issue. So this is just a few examples of some things that we've run across, some things that we've thought of that might be beneficial to our installers. If you have something, if you have a particular application, you want to run it by us, you can always call us or email us. We'll be glad to let you know if the M1EZ8 is going to be a good fit for that scenario.
Okay, great. Thank you, Brad, very much for all of that wonderful information. Again, hopefully we've got your gears turning a little bit on this. We've run into these cases, as Brad said, where we've thought, hey, it may not be exactly what they had in mind when they were designing the product, but wouldn't it just work great for that? And so that's kind of where we want you thinking about this product as you're running into, we hear from installers all the time, well, this customer wants this thing or this feature, and how can we make that happen? So keep EZ8 in mind when you're running into those kind of off-the-wall things, because it's very capable controller, very expandable, a lot of capacity for these logic statements, and there's just a lot of power in that, as well as the other ways that the EZ8 can talk to devices. Of course, you've got your input-output, which you would get from a Magic module on a much smaller scale, but also with the serial and the IP, that kind of brings it into more of the technology that we are seeing today and using today. And everybody wants everything on the internet. They want have notifications to their phones and that sort of thing. So all of that's there for you with the EZ8. Just definitely be keeping it in mind for that sort of thing. And we appreciate your time today. Certainly if you run into questions after the webinar just in general, or like Brad said, if you have an application you're like, I wonder if that'll work, give us a call, send us an email. You can find our information, contact information on elkproducts.com. and you can also find a lot of information on our products there. We also have a pretty good YouTube channel where we have some videos of things that we've done with our products, and this video will also be posted there. We'll be sending you a link to that as well as a copy of the presentation we used today, and I hope everyone has a fabulous Wednesday.